Okay, welcome back. So now let's move to V2. Okay, so to remind you that V2 basically we add the prop. Pretty much the same, nothing changed. We know how it works. We know how to control very well this case. And now we have this prop here, the chaff, the propeller. Have in mind that now we need to add a lot of refinement to resolve this curvature. But for the rest, nothing changed. And then the steps, the standard steps to do this, to create these lightning meshes, which is not a problem. So let's run this case. And we are V2. So let's go. We have the parallel scripts. Then here we have two scripts now to generate the mesh in parallel, which we're going to do because otherwise it's super slow. Here where we have a lot of refinement, and then to put the mesh in motion, but also to do all the splitting and so on. So when it comes to the mesh here, we have mesh. Okay, in this case also you have input geometry. You have a mesh with face groups. No, so it will be case V1. We're reading that geometry. So if you want to access. We already addressed that in one video, but we're going to work with V0, okay? But nothing changed. So when you have the mesh group, you can access that in the surface section, no? So it's not a big deal. So we work with V0. So let's open V0. Let's visit. So surface features, everything the same. We extracted everything. So we have standard steps. Read the geometry. So this is a new geometry that now we have the chaff, and basically is this body, everything in orange. So we have the chaff. It is in one single geometry. Well, as we save that surface independently, we can use it to add the region refinement. We have the propeller, the cylinder around the propeller, and a whole bunch of surfaces. So this is the chaff 1 or chaff 2 prop. So those will be this surface, and then the surface around the propeller there, the chaff. Okay, and nothing new. Everything is standard. Here we already have now the 20 million keywords. Now I recommend you to get it there because now here it starts to get expensive. So now in this case, the image, I put 0, 0. I don't need to put 6 because now everything is 6. So there is no need to have that redundancy, but if you want, you can put it or you can add more level there. Now all the surfaces that I see, so you have the whole boat 6.6, you have the propeller, and look at that, now the propeller is 8.8, and you can guess why it's 8.8 because we have a lot of curvature here, so to resolve all those small details, we need a lot of refinement. 8.8, propeller cylinder, also we put 8.8 to have everything the same resolution, and here's where we're going to enter into problems, because remember that dimensions here are very small. So this diameter, let me see, this diameter is 3 millimeters diameter. So get an idea and all the precision now, all the parameters now. So if you divide 8, those 3 millimeters will become very, very small, 10 to the minus 8. And be careful, and this is to stress. Control D, you have a writing precision here. So be careful and use a high value. Otherwise, you're going to have truncation errors. OpenFOAM and Snappy always is going to work in double precision. You compile it in double precision. But when you save the information, as you put here 6, and if your boundary layer is 10 to the minus 6, you are not going to save anything for post-processing. So be careful about that. And in my standard dictionaries, always put here 12. I always use binary. Is smaller files, less I/O. But honestly, also I have seen that it preserves better the information. Those imperfections that you see sometimes in binary, you don't see it. It shouldn't be the case, but it happens. Okay, so that's it. So final details that I want to include. And at this point, we are ready. So let's generate this mesh. So run mesh parallel. And this will take a while in 4 cores. But the new steps, now that after we have the mesh in parallel, if we want, we can generate the boundary layer. I'm not going to do it, but I'll leave it to you. But we know that it will work. But the new steps is move mesh. So we take the mesh, create baffle, recall previous tutorial, create baffle, split baffles, create patch, split regions, and now put it into motion. And here will be one small detail though that I want to stress something. Recall also that I mentioned this when you run check mesh at this point. It is a good standard practice to make check mesh a little bit more chatty. No? So you use this option, all geometry, all topology will give you more information. Now sometimes you can improve something there. And talking about here, we're already mentioned, but this case, geometry, I think geometry is one of the offenders, no? And already run that now, but use also surface check, okay, OF12, surface check and constant polymesh, and here you have, no, constant polymesh, is geometry, and if I would recall, it was chaff STL. So look at that. I'm using this when I have this error, but now I have another, and now the name is okay. Give me a minute to read this. Chaff. This is the file manipulated, and look at that is you have this tolerance. Look at that. It's telling you it's already since about precision, 10 to the minus 6 and so on. So that's why I mentioned scaling might be a solution to this. But look at that. You have a few issues here, back faces. But the other one, besides this, you have all the normals. And this is the file that I manipulated using Mesh Mixer. And the manipulation was only converting to object files. And sometimes that happens. So let me go here, constant, polymesh, and in the background the meshing is running. So geometry, so this is the one we open, okay? And just to show you that you have the shaft, but the other that I manipulated on Mesh Mixer, and I didn't do anything. The only thing that I did is I separated the faces. Now I created the groups. That's all, but the rest is exactly the same. You can see that they have differences, and this is to bring something. I don't want to go in details, but many times having this separation of faces can improve a lot. Your mesh, your final mesh. This issue with normals and so on, intersections, how they are computing, and the surface check. This surface check also will give you better output when you do this subdivision, and also you save it in OBJ format. Okay, so basically exactly same geometries. The only difference is that this one is in OBJ, and I spent some time to separate faces so it can detect it's basically the idea is here that as you have different face group, automatically will detect that, okay, this is another face and you should have there an intersection. Instead here, it cannot detect that. It should rely on those feature edges, but here you have already that information inside. So that is the difference, and that's why also from time to time I like to do this subdivision. We have seen that you have surface auto patch and so on. So there are many ways to do it. I work it with Mesh Mixer. Well, we leave the mesh running there, and let's wait for the result. Okay, we're back. We have a mesh. It took a while, as you can see. Finer surface refinement, you get this, okay, more time consuming. But in this case, we run check mesh, about 3 million souls, okay? The quality overall is perfect. What I was stressing, always pay attention to the number, how those polyhedra are, the breakdown. You start to see that how nice surfaces. It's not, it is going to run, but it might be an issue, okay? So identify where do you have those faces. But in any case, this is really good. No objection here. All the faces, quality perfect. And At this point, I'm not going to add the boundary layer. Okay, you know how to do it. But here, what we want to do now is the face selections. No? So look at it here. We have, and let's the face selection to put the mesh into motion. No? So let me run build in what we have. So we created the mesh, and I forgot to mention that in this case, now we go here and look at that we have, like in the case of the steering tank, we create the cellZone and faceZone. So we have one, you can create two, three, four, whatever. So nothing changed, same workflow. Let's access the solution there. And let's put a cut plane. And let me add surface edges. And what I want to see is there. There you go. So this is the new addition that we have. So see that you have a nice region and so on. Perfect. Okay, so castellation, we go to the snapping, you have it there, and now we have the boundary layer. So this is a good mesh. Okay, nothing to object about that, except the dimensions. And what I'm going to tell you here is that remember that we have here, you can see that you have this domain and the faces are meshing and so on. But here you have some pinch points and folding faces in that region that the tolerances are really small. So when I try to do the splitting, it gives me some error, and almost certainly that the problem is that scaling. I need to check it, but in any case, this is just to demonstrate the workflow. Okay, but we have it there, and what I want to show you also, let me go bam 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 bam. Your whole surface, very nice surface. Okay, so here adding the boundary layer meshes shouldn't be a problem. Even in the in the propeller, I think should be okay. So look at it, nicely resolved, but we have to use a refinement of 8. And to point out the issues that you are going to have, look at here this folding face, that this is corresponds to the intersection. No, okay, I have that region there, I think. Should be, no. Proceed. I don't see that. But there are some faces that are mismatching, and that is creating the problem now when I try to do. But everything's just precision and so on. Okay, but quite nice. This is a nice result. So let's do now. Let's put it into motion. So to put it into motion, let's move mesh, and it will do the steps. So basically, let's follow here. First step, I'll reconstruct. I'm going to do this in serial, by the way. Then create baffles. So remember that you have that face selection, cellZone selection. So here is going to use that to create the baffles. Then it's going to split the baffles. So now you have the topological splitting. And at this point, this is a valid mesh that we can put it into motion. Okay. This is some cleaning, but this step is giving me problems. The issue I'm telling you the precision, so it's not a big deal. But you can stop here and put it into motion. So instead of doing here, you will do it there. But just to show you the issue, and you will identify very easily what is the problem. So at this point, we have the regions. Look at the naming convention, everything we created, everything perfect. Okay, here's where we're creating the non-conformal couples now for the sliding meshes in OpenFOAM. And here you have targets or faces. So when you do this operation, it will give you this info there. And let's see what happens. And look at that already at this point. Look at that. The coverage is 2. It's already telling you that there is a lot of mismatch, and it's going to give you an error. So if you go back to the other tutorials, you will see that usually this was 1, 1, 1, or something close to 111, not this much, but here immediately 2 is a lot of mismatch. Actually, you have like interpenetrating faces from one region to the other. Okay, so that is what is failing, but here is putting the prop into motion. Okay, as I mentioned, at this point here, you already disconnected the two patches, so you can put it into motion. But in order to do the interpolation, the NCC, you need to enable in this step. But up to here, it's valid to put it into motion. And let me stop it here. I don't need to. You have the steps, and let's put a phone. And okay, see that we have the patches, everything there. And I want to see the prop. Okay. And we have also here. Okay. And put it into motion, and there you go. So everything that we have learned so far in action here. Okay, all techniques with no problem we managed to do that. Let me say, this is a complicated geometry. Again, I have to criticize this a lot. This 2-to-1 refinement is horrible. And honestly, I'm 100% sure that all the problems that you have in boundary layer is that refinement. Boundary layer and also the snapping and cell collapsing. Okay, so look at that, what I was mentioning here. Clearly, you see the region there. And let me enable these two. These are the NCC. There's a nice refinement. We go to step 0. In theory, they are perfectly matching, but these are the small issues that you have there. So see that they are interpenetrating, there are folded faces, you have some pinch points and stuff like that that is giving problems. And likely that is the error that I have. But you get an idea what is happening. That's the solution. I have to check this one. The solution is just scaling, in my opinion. So here, as you measure, you will see that we're almost in that precision that for sure should give you problems. So actually, let me roll there. So let me mesh one of these cells here, here. So see that it's very small precision. So when you see this small cell here, we go to 10 to the minus 6, 7, 8. Those are the errors that you see. Now, when you run check mesh, you will see very small edges. And actually, let me run that check mesh here, all topology. Okay. Uh, just for constant. So we have almost 3 millions, wedge prison, everything okay. Okay, so let's take a look at what is happening here now. We put in all a very chatty check mesh, now a lot of verbosity. So look at that here, you have this first cell of 20x, a set of 28 cells. So as you visualize this, you will see where you have these faces, and everything it is in that interface in the edge of the NCC patches. So remember, when you run that one, everything is safe here. Okay, so you have all sets, and then you can access that information. So this is already, you have a lot of cells there that are giving you issues. Look at, dimensionally speaking, look at that. This is very small now, this dimensions, the box around the domain. Then we look at minimum volume. This is already an issue, and when you look at the volumes, you will see that you have those small volumes in that NCC interface. You have these these faces now with negative volume decomposition. They are in that region, okay, of the NCC, and many, okay, short edges also, you have it there. So and near points also, this is, look at that, the tolerance that you are there. So this is those pinch points that you have there. So, and everything, when you visualize that, most of these errors are in that region of the NCC region. So another no standard practice, not only the standard check mesh, but use those other options in check mesh now to make it more to increase the verbosity. So all geometry, all topology, and then you have these right sets and right surfaces to save everything so you can visualize. This also, when you put the body into motion, it would save the fields to of the coverage. Then you can visualize the coverage and so on. Okay, before uh, summarizing, to remind you to put the propeller in motion, we're still in V2. Go to in constant. Remember here you have the dynamic mesh dictionary. Here's where you set all the motions globally. Then you will have the boundary conditions here. We're not setting the case, but it's similar to the previous that we run the tutorial 5. So to mention here that you have the regions, you create everything, and here you have your axis of rotation you need to define. And as usual, you know your geometry. So basically, this is the case, and I think this is sketch. And basically, that is the axis of rotation, this one. So compute that unit vector, put it there, and pretty much that is okay. We're ready to go. So I have to say at this point that this is it. Okay, our 6 structure tutorials. So let me go back. 6 cases. We went from the basic, adding different complexity, different techniques, and so on, to probably the most complex case that we address in this structure tutorial, which is this one. And at this point, I'm quite sure that you are able to tackle any kind of problems. I have to, my final conclusion about snappyHexMesh. It is a good tool. It works, but honestly, this 2-to-1 refinement rate is a big issue for me. And if I don't need to use Snappy, I don't use it. I use something else because I know I get perfect results, okay? But if it is a requirement for me that I need to use Snappy, I use it. I know how to control things very well, and I get very good quality meshes. But always there are some small issues, and you need to live with those small imperfections. Don't try to fix it because they can be really tricky to fix them. And usually the fix is super small surface meshes, which probably would be very likely a waste of time. Other big advice, don't try to get small meshes. Small meshes are pretty much in Snappy. They're useless. So don't be, let's say, don't try to save memory cells. Just go ahead and have resolve your geometrical features. We have seen that you have a curvature that it is recommended to put one cell per 10 degrees, okay? And then small gaps, also put at least 2 cells, capture all the features and put uniform surface refinement. And I think that is more than enough to get good meshes. With this, we're done with all these structured tutorials. Probably with this bolt, I will do another video to show the usage of the mesh with the regions in the STL, but it's pretty much the same. We're pretty much done. Probably show that this geometry with another meshing tool, which will be ANOVA. But from this point on, we move to some other cases. I listen to suggestions. I'll send in the community page on YouTube. Just send a suggestion, video description. If we read that message, we can do more videos. So thank you for your attention, and hopefully we'll see you many more videos to come. Bye.